Hey guys, how's it going? This is Ben from Chegg Tutors here, and today we're going to be covering the statistics concept of standard deviation. So, in this video, we're going to go over the definition of standard deviation, and then we're going to look at a few sample problems to help you guys get acclimated to this concept. So, the formal definition of standard deviation is something along the lines of the square root of the variance. So right now, this doesn't really mean anything to you. So right now, you guys can think of it as the spread of the data, or how close the data on average is to the mean. So to illustrate this concept, let's imagine you have this data set. Let's say we're measuring the ages of random people, and let's say we sample 3 people, and their ages are 42, 43, and 44. So here the mean, which we can represent as x bar, is 43. That's pretty simple. And if we look at our data, it's all pretty close to the mean. 1 point is the actual mean, and the other 2 are 1 away. So here we can say that the standard deviation is pretty low. Right now we're just going to be using the terms low and high. We're not going to actually calculate the standard deviation yet, just to let you guys get used to this idea. So when the data is all really close to the mean, we can say that it has a low spread, and we can say that it has a low standard deviation. Let's consider, on the other hand, the same kind of example but with different values. Let's say that we have 43, and we also get 33 and 53. So here again, the mean is 43, but this time, 2 of our points are 10 away from our mean, even though 1 of our points is still the mean. So this time, the spread is a lot higher, and our standard deviation is a lot higher. So even though the mean of both of these data sets is the exact same. So standard deviation tells us, once again, how far on average some point in your data set is away from the mean. So the higher standard deviation is, the further away on average a random point in your data set is going to be from your mean, and vice versa. So now that we have this kind of concept down, let's look at the formula to actually calculate the value of a standard deviation. Here it is. Looks scary, it's really not. So this symbol on the left represents standard deviation. Oh, oops. Okay, so that's our standard deviation. So here we have the root of some big thing. So here is the variance. So everything underneath the root sign represents the variance, which you don't really need to know. So what does everything else mean? Well, your x bar is your mean of your sample or your data set. Mean of data is your x bar. Your xi is going to be every data point, every single one. So this sigma sign on the left, all this means is we start at I equals 1 and we go to n, where n is your number of data points in your sample. So let's say let's go back to our previous example here, n would equal 3 for both. So we just go from 1 to 3, meaning we hit 1, 2, and 3. So this would be data point 1, this would be data point 2, and this would be data point 3. So all this means is that we're going to perform this operation where we take whatever data point is we're looking at, subtract the mean from it, and then we square the difference, and then we take all these square differences and we're going to add them together. This is what the sigma means. So we go through each data point, we go to 42, subtract 43, so negative 1, we square that, we get 1, and we do that for the rest, the other 2 data points, and then at the end we add all those squared values together. So this gives us our numerator here. And then we divide it by n minus 1. So remember, recall that n is equal to size of data set, or in other words, how many people we sampled in this first problem, so 3. So 3 minus 1 is 2. So we divide this sum by 2, and then we square it, and then we have our standard deviation. So yeah, pretty simple. Let me show you an example problem and a simple way of doing this. You can use this kind of table. So it's kind of small, so I redrew it. It looks a little cruder, but it'll work. So you make 4 columns. Your first column is going to be all your observations. So let's say let's increase our age observations to 5. So n equals 5. Your second column is going to be your mean. It's going to be the same for each one, but it's going to be helpful because your next two columns have to use this mean. Your third column is going to be the difference between your current observation and the mean. And then your fourth column is going to be the square of this. So all of these are values that we talked about in this formula up here. We're just going to put it in table format so it's easier for us to observe what happens. So the first thing we do is calculate our mean. So you look at our data set, the average or the mean is going to be 44. So we can write 44 for each space here underneath this column. Pretty easy so far. Third column is also pretty easy. Now, for each row, we take each x value and subtract the mean. So here it would be 46 minus 44, so 2. Next one will be negative 2, and so on. 0, 1, and negative 1. And in the final column, we square all these values in the previous column. So 2 squared is 4, negative 2 squared is still 4, 0 squared is 0, 1 squared is 1, and negative 1 squared is 1. So, pretty easy stuff, and you might ask me, well, then, why do we need this kind of table to solve this problem? Well, it's because it gives you all these values at the end, all these squared values that you can just sum. So the sum of this would be 4 plus 4, which is 8, plus another 1, so that's 10. And you can just substitute this whole numerator for that 10. So that makes it a lot easier. So instead of you having to keep track of each squared value in your head and redoing these steps over and over for each data point, you can just draw this table. So remember that n equals 5. So to finish this off, remember that your standard deviation is equal to the root. So now we can plug in just 10 for this numerator divided by n minus 1, which is 4, because remember n equals 5. So 5 minus 1 is 4. So the square root of 10 over 4, so this is 2.5. So the square root of 2.5 is around 1.6. So now we can say that the standard deviation of this data set of ages is around 1.6 years. So this quantifies the spread of our data using the standard deviation. And now going back to the definition, the formal definition of standard deviation, which is the square root of the variance. Remember we said that everything under the square root is a variance. So if you just square your standard deviation, so if you just take this root away, or you just square this value, you get the variance. So the variance is just the standard deviation squared, and in this case it's going to be 2.5. Okay, so that was an example of how we would apply standard deviation to a statistics problem, and I hope everything made sense.